In this lecture, I'll discuss interference, which is an interaction between two waves of the same type. This is different from previous lectures in which I've discussed how a wave interacts with a change in media, how it behaves at a boundary. This type of interaction, that is interference, occurs within one medium, but between two waves of the same type. For example, two sound waves can interfere with one another. The mechanical wave in this case is a very simple example. Let's consider a wave propagating along a rope and a second wave propagating in the opposite direction along the same rope. At some point in the middle, these two waves will collide, and at this point they will interfere. Waves superimpose, so the height of the two waves will add up at this point. And then afterwards, the waves will continue in the same way they had, with the same heights. This means that afterward, you'll see the same pattern with the waves traveling in the same direction they were originally. At this point, there's interference, and this interference is called constructive because it is additive. There's also a second type of interference called destructive interference. The idea behind destructive interference is that when two waves of opposite amplitudes interact, they cancel out. Let's again consider our example of a mechanical wave, a bump in a rope that is traveling in a particular direction. And let's consider a second bump that's below the rope. If these two disturbances are traveling towards each other, they will interact at some point in the middle. And in this case, instead of observing a greater amplitude, you will observe a lesser amplitude. If these two amplitudes are equal but in opposite directions, you will observe a completely flat second in the rope. This is called completely destructive interference. If, however, one bump is larger than the other, you will observe a smaller bump in the rope when the two interfere. This additive property is called superposition. Other types of waves interact in more complex ways through interference. It is said that these types of waves form interference patterns. Let's consider two sound waves which are interfering, as I've represented in this drawing. I'll say that the lines represent the crests of these sound waves, meaning the points at which the pressure is the highest. This means that directly in the middle, the pressure is lowest. In this drawing, the points where two lines coincide represent points of constructive interference, because these are points where both of the waves have reached the highest pressure. At other points, one wave is at a crest while the other is at a trough, the lowest point of pressure. This means that the two waves have opposite amplitude and will destructively interfere completely. At other places, you will observe incomplete interference, both constructive and destructive, creating a complex pattern. Knowledge of this type of interference is very useful for people who design concert halls, because it would be a pain to sit in a place like this where there's completely destructive interference. If you sat here, you wouldn't be able to hear the orchestra.